Video number 3 on linear programming. This one I would think could be seen more like on the test. So if I were you, this one I'd make sure I know how to do for sure. That last one we did was kind of crazy. This one not quite so bad. So don't worry about this part here. This was just from the daily quiz, just showing you where we got these equations from right here. We just took all of these equations right here and put them in to our system. So I think possibly, more on the linear programming side, you're probably going to be given a set of constraints. These are called constraints. You'll probably be given your objective equation, which is right here. And then it says it wants you to determine the minimum and maximum values. So you're going to have to find both the min and the max based on these constraints. So the best thing I can tell you to do is with these constraints is go ahead and start graphing them. So let's go ahead. Oops, sorry. Got a little bit out of craziness there. So let's go ahead and start graphing them. X is greater than or equal to 0. So here, that's X is this vertical line right here on the y-axis, greater than or equal to 0. So we're looking this way. It does say that y has to be greater than or equal to 0. So again, that's going to be your x-axis right here, and then it's going to be this way. So we know we're up here. We know that x has to be less than or equal to 10. So let's go ahead and call this 10 right here. So we draw a line here at 10. We know that we're over here, so now we're just dealing with this part. And it says that y has to be less than or equal to 20. So I'm going to come up here to say, call this 20 right here. And it has to be less than or equal to 20. So now, if you look at it kind of sort of, we're looking at this box for right now, okay? Then we have these two equations right here. To graph this one by intercepts, so to find the x-intercept, I'm going to go ahead and let y be 0. So if y is 0, if I plug in 0 for y, I get x equals 5. So x equals 5 when y is 0. So that's the point. So it has an x-intercept of 5, 0. So if that's 10, that's got to be 5 right here. So that's 5, 0. The y-intercept is going to be when x is 0. So the y-intercept is when x is 0. So I plug in 0 here, I get y equals 5. So that's 20. That means 5 is going to be like probably about right here. It's got to be that equation, that line right there. And it says it has to be bigger than, so now we're looking at this section right up here. So this section is gone. We're not looking at that part anymore. Then we have this equation here again. So if I do it by intercepts, the x-intercept is going to be where y is 0. So if y is 0, x just equals 18. So that means I have to come out here where x is 18. So if this is 10, say this would probably be like 20. So 18 would probably be about, say, right there-ish. The y-intercept is when x is 0. So if x is 0, then y equals 9. Because if I get x equals 0 here, I get 2y equals 18. Divide 18 by 2, that's 9. So this is 5. So this is like 10, so 9 would be about like right here. I'll go ahead and call that 9. So we have this equation here. This has to be less than that. So it's going to be this area. So now we have our points. So now we can see that there are points all along this bounded region right here. There's 1, 2, 3, 4, 5. So there's going to be 5 test points that we have to do. This one's easy. We can totally see this one. It is 5, 0. So we need to test that point. We also need to test the point 0, 5. Okay, we need to test this point here, which is 0, 9. That one's easy. This one right here, which is pretty easy, that's 10, 0. And then the one that we don't quite know is this one right here. So to find this point right here, remember this equation was this one right here, x plus 2y equals 18, and then we're going to just let x be 10. So 10 plus 2y equals 18, and then we subtract 10 over. We get 2y equals 8, divide by 2, y equals 4. So it's, sorry, I did all that math right there without you guys seeing, I apologize. So to find this point right here, I took the equation that it was on, which was this equation, and this x was 10, so I just put 10 in for x, and I just solved. I get y equals 4. So this is the point, 10, 4, and that's, so I have to 1, 2, 3, 4, 5 points I need to check with this equation right here. And I'm looking for min and max. So Q equals 70 times 5 plus 82 times 0. And then I'm going to take 70 times 0 plus 82 times 5. And then I'm going to take 70 times 0 plus 82 times 9. And I'm going to take 70 times 10 plus 82 times 0. And the last equation will be 70 times 10 plus 82 times 4. Again, I just took each one of these points, which are an x and a y, and I just plugged them right in for x and y into this equation right here, which was my objective equation to find min and max. So I'm trying to find the smallest number and the largest number. Okay, so get to work. Calculator on. All right, here we go. I'll bring my calculator into view. You guys can maybe see what's going on here. So I just take 70 times 5 plus 82 times 0. Hit enter, and I get 350. So this one equals 350. Then I'm going to take 70 times 0 plus 82 times 5. That gives me 410. So this one here is 410. Then I'm going to take 70 times 0 plus 82 times 9. That's going to give me 738. Now this guy here, 70 times 10 plus 82 times 0, that gives me 700. Now the last one, 70 times 10 plus 82 times 4, that gives me 1028. So again, what am I looking for? I'm looking for the min and the max. Well, this one right here is the min. It's the smallest number. This one right here is the max. So this point was the point 50. That's my min. This point here, which was 10.4, that's my max. Okay, and we're done. That's linear programming. Again, not too bad. You guys can do it. Hopefully those made sense. We'll see you soon. Bye. Math 1050. Slide 30.